Napindot ko ba? Ay, ayan na pala. Okay. So, let's discuss the last chapter in inorganic chemistry part of this subject, no? Which is gases, no? Okay, so gases. Ano ba yung mga gases? There are some elements that exist as gases under normal condition. When you say normal condition, usually that's 25 degrees Celsius, the ambient temperature, and 1 atmosphere, no? So under normal circumstances, some elements exist as gases, no? For example, yung hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, and the noble gases, no? Okay. So our gases may be elemental, that means iisa lang yung atom, or it could also be a compound, no? Wherein may different atoms combined, no? Ayun. So, ito yung dalawang uri ng ating gases, no? So, may elemental, may compounds, no? And under normal conditions, all these examples in here are gases, no? For example, yung HCl gas, yan yung ano, di ba pag nagbukas ka ng muriatic acid, di ba umuusok, di ba? Yung usok na yon, that is HCl gas then. Yes, it exists as liquid and as gas at the same time, no? Okay, so yun. Yung smoke doon, that's hydrochloric acid or hydrogen chloride, no? So that's delikado kasi it can burn your ano, your airway, no? Especially pag nasira yung alveoli inyo, patay talaga, no? So do not sniff all the gases, ha? Hindi lahat ng gas inaamoy, ha? So yun lang. So those are some compounds that exist as gases. CO2, ito yung ina-exhale natin. All our burned up carbohydrates, no? Yung mga pinakain nating food, they are eventually turned into carbon dioxide and water, no? So combustion reaction din kasi nangyayari in our bodies, no? So we give off carbon dioxide. The water that is the product of the combustion reaction is used by the cell, no? Or sometimes we excrete them, no? Nilalabas natin yung mga water na products in the form of urine or sweat, or some of them are used by the cell, no, to maintain homeostasis, no? Okay, so yun lang. Ano pa yung mga gas, no? Itong ammonia, I don't know if nakaamoy na kayo nito, no, pero upon checking some yung safety boxes, yung mga emergency box. Pag tinitingnan ko yun, meron silang may ammonia container sila na ammonium bicarbonate yun eh. Na pag inamoy mo, may gising ka talaga sa sobrang baho, no? Para daw sa mga para daw yun sa mga nahihimatay, no? Kaya may ganun. Magigising ka nga, kaso mamamatay ka sa baho ng ammonia. Mabaho to eh. Ano pa ba yung mga gases, no? SO2, N2O, NO2, these are some toxic gases that are found in the atmosphere. They contribute to the acid rain, no? So, yan. So, medyo delikado sila, but they exist as gas, no? Okay. So, yan yung mga example ng gases. You do not have to remember them, no? Just be familiar na, uy, ito gas to, under normal conditions, no? So, yan. So, these are our examples of gases under normal conditions, no? And kung titignan natin sila as a whole, we can see some properties that they exhibit, no? So kung titignan mo sila, mayroon silang common denominators, no? So saan sila common, no? So number one is that gases assume the volume and the shape of the container, no? Yung gases natin, unlike solids and liquids, no, na fixed lang yung volume, yung gases, they spread out, no? Kumakalat sila sa hangin, no? Yung that means, no, since kumakalat sila sa hangin, their shape is variable, no? Iba-iba yung shape ng ating gases depending on its container. It could be cube, kunwari nasa room ko ngayon, yung gases dito, naka-shape siya as cube, no? Kasi cube tong room ko, no? For example, lagay mo siya sa water bottle, the shape of the gases there will look like water bottle as well, no? So gases assume the volume and the shape of their containers, no? So they spread out, no, to maximize the entirety of the container, no? Kumakalat siya. So yun, they spread out in the process called diffusion, no? So yun, so kumakalat, no? Kaya for example, may nagluto sa kusina, no? adobo. Gutom na ako eh. So, may nag-cook ng adobo. You can smell it even in your bedroom, no? Even sa next na bahay, no? Maamoy nila yan because gases tend to, ano, to spread out itself, no? Kumakalat talaga siya sa hangin, no? Okay, so yun lang. Another common denominator of gases is that they are the most compressible state of matter. So when you say most compressible state of matter, we can compact them, no? Pwede mo sila ipitin para lumiit ang volume. For example, itong upuan ko dito, pag pinindot ko tong nasa gilid, no, yung latch, tignan nyo bumaba ako. Pindutin ko ulit, di ba? Nag-enjoy lang. What happens is that yung weight ko, no, when I press that latch, no, yung weight ko, ginagamit yun to compress the gases, no. Iipitin niya yung gases sa ilalim, no. Yun yung concept ng hydraulics. Nag-enjoy yan, no? So anyway, so yun lang yung idea that gases are the most compressible state of matter, no. You can compact them to form smaller volumes, no. For example, yung ito, Lysol, no? So, may liquid dito, may gas din, pero yung volume is kinompact nila in this, ilang liters to? Hindi ko alam kung ilang liters. Basta inipit nila yung gases na nandito. No? So, I don't know how much gases are there, pero ayoko na isipin niya kasi baka mamaya sumabog pa yan. No? So, anyway, so yan, gases are the most compressible state. No? You can compact them. Another example would be your car tires. No? So, yung car ninyo, yung gulong nun that contains lots of air, equivalent to, ewan ko kung ilan, 37 PSI ata yun, no? So, 37 PSI is way higher than the atmospheric pressure. No? So, yun lang. So, those are some examples of gas being compressible. No? So, pwede mo sila ipitin. No? So, yung mga molecules na magkakahiwalay, you can compress them. No? So, magdidikit-dikit sila. Okay? Another property or characteristic of gases is that they will mix evenly and completely when confined to the same container. So, yun nga, kagaya nga ng, let's say, adobo, no? Yung scent ng adobo, kumakalat siya sa buong bahay, no? When cooking, no? Kasi, ganun ang tendency ng gas, no? They diffuse out, no? So, kumakalat sila in order to maximize the space they occupy, no? So, ganun. So, hindi lang naman yung mababango yung kumakalat, no? Meron ding mababaho, no? So, ayoko na lang magbigay ng example. Alam nyo na yun, na. So, yan. Kumakalat sila sa hangin, no? You cannot contain it, no? Magle-let it go talaga yung amoy. Kaya ganun, na. Ano pa? Gases also have lower densities compared to liquids and solids, no? Why? Because of the volume, no? Remember the formula for density? That's mass over volume, no? Okay, so when you have big volume, mataas ang volume mo, ano mangyari sa density? The density will be low, no? Bababa yung density. Why? Because the relationship between density and volume is inversely proportional, no? That means if mataas ang volume, that means malaki yung denominator dito, any number divided by a big denominator will give you a small quotient, no? So that means kapag malaki yung volume, mababa yung density, no? And that's true for gases, no? Bakit, no? Kasi yun nga yung tendency nila. They tend to occupy the entirety of its container, no? Sasakupin niya lahat ng space na pwede niyang sakupin. So as a result, its volume will be increased, hence the density will decrease, no? So yan lang. And whenever we have gases, no, we have gases around us, no, 'di ba? Yung mga gases na yon, they actually exert some pressure on us, no? So tinutulak tayo ng gases, no? So we define the pressure in physics as the force exerted by something over the area it covered, no? For example, yung air, it actually exerts force around us, no? over certain area, no? So we can actually measure how much gases we have depending on the pressure, no? So that means if mataas ang pressure sa paligid, that means the force exerted by gas molecules is mataas, no? And since mataas yung force nila, ibig sabihin marami sila, no? Okay. Okay. So yun lang. These are the units, no, used in determining the pressure of gases, no. So these are the units. Be familiar na lang. The common unit is the atmosphere. However, the SI unit is the Newton per meter square or Pascal, no. So this is the SI unit. These are the common units, no. So one atmosphere is said to be equal to 760 millimeters of mercury, or equal also to 760 torricelli or torr, no. So paano nila na measure to? So before the invention of modern pressure gauges, meron tayong tinatawag na barometer, no. Barometer is an instrument used to measure the pressure in the atmosphere, no. So in it mayroon tayong mercury, which is a liquid metal, and we have a capillary here wherein the liquid can travel to into, no. So pwede pumasok diyan yung liquid, no. And ang idea is that the atmosphere pushes us, no. Yung gas molecule, they bump on our particles kasi, no. Kunwari, yung gas molecules, tumatama yan sa kamay ko ngayon, no. So that means since gas molecules are hitting my hand, no, that means may pressure silang ine-exert sa akin, no. So bumubunggo-bunggo kasi sila sa katawan ko, no. So may pressure, no. So ganun din. That's true for all stuff here on earth, no. That the air around us exerts pressure on mercury, no. So itutulak niya yung mercury in such way na yung mercury, since tinutulak siya, in order to balance the forces, it will go inside the capillary to a height of 76 centimeter. Almost 1 meter yung tinaas, no. If you convert 76 centimeter to millimeters, you will have 760 millimeter mercury. So napaka-literal ng meaning, no. Yes, yan yung ano, kwento behind this 760 mmHg, no. So when there is an atmospheric pressure pushing the mercury liquid, yung pag-akyat ng mercury liquid natin is 76 cm yung height niya, no. And yun, ginawa siyang unit of pressure, no. So depending on the height of the mercury, that means iba-iba ang pressure. The higher the mercury is, that means the higher the pressure is there around us, no. The lower the mercury reading, no, the height of the mercury, ibig sabihin mababa yung pressure around us, no. Si Thor naman, isa siyang copycat, no. And I really don't know the story about Thor, pero same lang sila ng nakuhang idea. I don't know why, pero yun, tanggapin natin. So we sometimes use Thor, no. Minsan millimeter mercury. The other common unit is bar, no. So instead of 760, I think that's 750 bar, no. Yung 1 atmosphere. Although ang gumagamit niyan is kami-kami lang din mga chemist, no. So hindi naman ginagamit 'yan ng ibang tao. Kaya hindi na sila nilalagay sa common units, no. Okay, so anyway, these are our common units. 1 atmosphere, this is equivalent to 760 millimeters of mercury, or equal also to 760 torr, no. In the SI world, no, sa mundo ng SI units naman, 1 atmosphere is equivalent to 101,325 pascals, no. Sir, kailangan ko ba kabisaduhin yan? Kagaya ng sinasabi ko, sinasa puso yan, no. Hindi ko sinasabing kabisaduhin, pero kailangan isa puso, no. Okay, so yan yung ating mga conversion factors, no. Kasi mamaya we are given 1 unit, no, tapos i-convert pa pala siya sa isa pang unit, then we should be able to convert them, no, by using these conversion factors, no. Okay. So by the way, may ganito pala to. Hindi ko napansin kanina. So by the way, ganito yung concept ng atmospheric pressure, no. Okay, so kunwari you start here sa Earth, no, then going up sa atmosphere until the until the outermost layer na atmosphere natin, no? So, may air doon, no? Kahit even sa outer space, no? Even in the International Space Station, they experience air drag, no? May molecules pa rin ng hangin doon. Although very, very onte compared that of the surface level ng Earth, no? Kaya yung ISS, no? International Space Station, it needs reboost, no? Para umakyat uli siya sa atmosphere, no? Umakyat siya ng orbit. Anyway, so ito kasi yung visualization niya, no? For example, we have this certain portion of area sa Earth, no? Yung air na nagpupush sa kanya ay ganito kataas, no? Lagpas-lagpas pa yan dyan, no? So, lahat ng gas molecules na nandyan ay tinutulak yung certain area na yon, no? Bakit siya tinutulak? Because of gravity, no? Molecules are affected by the gravitational pull. So as the Earth pulls the atmospheric gases, that means the gases exert pressure on us, no? Kaya nafe-feel natin yung atmospheric pressure. And depending on your elevation here on Earth, the atmospheric pressure changes. The higher you go sa surface level ng Earth, that means mas mataas, mas mababa yung pressure na may experience mo. Bakit, no? The answer is that as you go higher kasi in elevation, umuunti na lang yung gas particles, no? Until mawala na siya. Pag nawala ng gas particles, nasa kalawakan ka na, no? So, ganun lang yung idea. So, as you go higher, in elevation, the atmospheric pressure decreases. Now, for example, dito sa Maynila, that's 1 atmosphere. Punta kayo ng Baguio, that's less than 1 atmosphere, no? Okay, so yun. And punta ka pa sa outer space, syempre, way less than the atmosphere, no? You will experience vacuum in space na, no? Okay, so yun lang yung idea. How do we measure gases ba? No? So the old method of measuring gases is through the use of barometers. No? So ganito yung itsura ng barometer before. You have a vat here with mercury. And ito yung column wherein the mercury will displace kapag may pressure sa paligid niya. No? Okay. However, we do not use this. Hindi na natin ito ginagamit. Why? Mercury is toxic. No? So, ayaw natin sa mga toxic na bagay. Kaya, we do not use them anymore na. Okay? Other than barometers, we also use manometers. No? So, this is an example of a manometer. You have a flask here that is connected to this stuff in there. You have a YouTube here. No? YouTube talaga tawag dyan. No? And then you have a stopcock and then the vacuum chamber or open chamber, no? So andito yung mercury, no? So whenever your gas is expanding here, that means this gas will push the mercury up, no? Pwede niya i-push pataas yung mercury. Okay, so yun lang yung idea. Tapos ang ginagawa to get the pressure is that you just get the difference in height. Then, yun, millimeter mercury na yun, no? So ganun lang ka straightforward. Yung millimeter mercury, you can convert that to atmosphere. No? Sometimes manometers are closed tube. Sometimes they are open tube. No? So, ano yung difference? No? Pag closed tube, close yung ending dito. No? So, limited lang yung pwede nyo gawin. No? Okay, so that also means that the atmospheric pressure doesn't affect the experiment. No? Walang count yung atmospheric pressure kapag closed tube system tayo. Okay? So that means whatever this height is, that is equivalent to the pressure of the gas itself. No? Okay. So yan lang. Yan yung closed tube. Nakasarado doon. Ito nakasarado din yan. No? Okay. So yan. So kung ano man yung height na yan, that is the pressure of the gas itself. No? For open tube naman, mapapansin natin dito is that open yung ending dito. Dito close. Ito open. Close. Open. Close, open. No? So, dito open tayo. So, that means, itong open tube natin, we have to account for the atmospheric pressure, no? In order to get the correct pressure of the gas, no? Okay? So, yung makukuha mong height difference, that is not the pressure of the gas itself. You have to account for the atmospheric pressure, no? So, that's why the pressure of the gas is the sum of the pressure of the gas itself, yung height difference, plus the atmospheric pressure, which is usually 1 atmosphere, no? By the way, this is not included in your quiz, no? Sinashare ko lang. Okay, share ko lang yung idea na yan. So, yan yung mga old methods in measuring the gas pressure, no? But ngayon, we use pressure gauges na, no? Such as use sa mga sasakyan. Ano pa ba? Saan pa ginagamit yun? Sa mga compressor, no? Yun, may mga pressure gauges na sila, no? Though the concept is still the same, no? Whenever the gas is exerting force in the instrument, no? Habang tinutulak ng gas yung instrument, may corresponding reading yon sa pressure gauge na. So ganito yung old method niya. Ang new method is using the pressure gauges na. And ngayon, punta naman tayo sa relationships ng pressure of a gas with other properties of matter. No? Let's proceed with Boyle's law. Gas laws na tayo ha. Teka lang. Saan na tayo ngayon? So second part na tayo. We will now observe how the gases behaves under different conditions na. So yan. So let's have Boyle's law no. So looking at this graph no, this is an isotherm graph no. What can we observe is that when you increase the volume of the gas, the pressure decreases no. One good example of it is that kunwari may syringe kayo sa bahay, tanggalin nyo yung needle. Pag nilagay nyo yung needle, masusugatan kayo eh. So, yung syringe, tanggalin nyo yung needle, idikit nyo yung mouth ng syringe dito sa daliri nyo, tapos i-pull nyo yung dulo. No? So, pag pinull nyo yung dulo, that means the volume is increased. However, you will feel suction. Yung suction na yon, that is because of the decreased pressure. No? Gawin nyo naman yung kabaliktaran. For example, you start with 10 cc of air. No? Tapos i-push nyo yung, ano tawag doon? Basta yun, i-push nyo yung nasa dulo ng syringe. No? So, makikita nyo, the volume will decrease. However, in your hand, no? Dun sa tumatakip sa mouth ng syringe, may experience nyo yung parang masakit, no? Siyempre, kahit walang needle, masakit yun kasi mataas yung pressure, no? So, yun lang yung idea. So, what can we observe is that the pressure of a gas is inversely proportional with the volume of the gas, no? So, that can be written mathematically as the pressure is inversely proportional with volume, no? So, paano sinusulat yun sa math, no? Pressure is inversely proportional to volume, no? Para siyang alpha, no? Pero this is a proportionality, no? Proportionality symbol. So, yan. So, hindi yan alpha. Parang alpha lang, no? So, that tells us about the mathematical relationship of the two. So, ano meaning kapag inversely proportional? When you increase the pressure, what will happen to the volume? It will decrease, no? If you increase the volume, what will happen to the pressure? It will decrease naman, no? So may opposite direction sila, no? So yung isa tataas, yung isa bababa. So yung isang tataas, yung isa naman yung bababa, no? Okay? So mathematically, no, we can derive some equations out of this proportionality when we introduce a constant, no? So, i-rewrite natin to mathematically wherein we can introduce a constant, no? The constant of measurement, no? So, paano yan? Itong a proportionality symbol, gagawin ko lang equal sign. Though, maglalagay ako ng k as my constant, no? Okay? Then, I will combine the two, no? So, PV equals k, no? So, yan. So that means if you multiply pressure and volume, you will come up with some constant, no, na fixed, no. So the constant in your first condition and the final condition will be the same kasi constant nga, no. So that means yung initial pressure mo and the initial volume, pag pinag-multiply mo yon, that will give you a constant. Pag binago mo yung system, you will have the second reading. Second reading ng pressure and second reading ng volume. When you multiply those numbers, it will give you the same constant as well. So since parehas lang yung K, we can say that P1 V1 is equals to P2 V2 na. Same lang naman ito. So we can equate the initial condition with the final condition. So may mathematical relationship tayong nakuha. No? Sana all may mathematical relationship. No? So ito yung equation ng Boyle's law. No? P1 V1 equals P2 V2 wherein the 1 indicates your initial state, kung ano yung initial reading mo. The 2 indicates the final state, no, or the final condition. Okay, so yun lang. Let's have some examples. No? So, a sample of chlorine gas occupies a volume of 946 ml at a pressure of 726 millimeter mercury. What is the pressure of the gas? Oy, gumagana pala yung yung nag-post kasi ako sa Twitter. Yung my face, tapos the BPI QR code. May nag-send ng 30 pesos. Share ko lang. Kala ko ano yung nag-notif. Legit pala yun. Sana 500 na lang, di ba? Anyway. Sino kaya yan? So, thank you sa 30 pesos. No? more pictures. Baka magulat kayo pag nakita niyo yung Twitter ko. Mas stress kayo sa mga ginagawa ko sa buhay. So, Teams na lang tayo mag-usap. So anyway, so yan, let's have this example na. So 946 ml yung volume ng gas and the pressure is 726 millimeter mercury. So this is our initial reading, di ba? On the final state of our matter, no, after doing some changes, the volume is reduced to 154 ml. No? So bumaba yung volume. What is the pressure of the gas? No? So looking at the equation, bumaba yung volume. That means the pressure must be increased. No? So dapat tumaas yung pressure. So let's check no, kung ano yung value ng pressure na yan. So this is the Boyle's idea. No? Ito yung Boyle's law. No? So alamin natin yung mga given. No? Usually, kung ano yung nilagay sa harap ng question, yun yung initial condition. Kung ano yung nasa dulo, yun yung final condition. Kaya nga, ito yung pinakamadaling quiz ninyo. Kasi merong nag-take na dito na naka-perfect na. Hindi ko alam kung classmate nyo yun. Sa ibang section ata yan. But anyway, no, madali lang kasi talaga to, di ba? So, usually, mga unang binibigay, that's the initial condition. So, initial pressure, 726 mmHg. Initial volume, 946 ml. Final pressure, yan yung hinahanap. Volume, 154 ml. By the way, no, the units must be the same, no? Dapat kung ml to, ito ay ml din. Kunwari ito ay liters, tas ito ay ml, you have to convert liters to ml or ml to liters, no? Kaya bahala, no? Basta the units must be the same because later on we should cancel the unnecessary units, no? So we can arrive with the correct answer. Okay? So, to solve for P2, ano lang kailangan gawin? So, ito si P2, may katabi siyang V2. So, if we divide both sides by V2, we will have the equation, ayan, no? So, divide both sides by V2 so we can cancel it, no? Cancelled, yan. So, we will have this equation, P1 V1 over V2, no? So then you have to plug in all your information. Take note that the units will cancel eventually, giving you the final answer of 4,460 millimeters of mercury. No? So ganun lang ka-easy, di ba? Yun lang. Anyway, so punta naman tayo dito sa yung mga next gas laws dito na lang sa PDF. Okay. So andito naman lahat eh. Okay, so again, Boyle's law. When you say Boyle's law, there's an inverse relationship between pressure and volume now. Okay, so we can derive a relationship between two sets of condition using this equation, P1 V1 equals P2 V2. Na. Next one is Charles' law. So ano sabi ni Charles' law? According to Charles' law, the volume of a gas is directly proportional to the temperature changes. Na. Nabalitaan nyo to kagabi doon sa 24 oras, yung alcohol na sumabog sa sasakyan. So kung nanonood kayo ng balita, alam nyo yun. Na kagabi yun eh. Habang kumakain, ano ba kinakain ko nun? Malungkot na food. So anyway, so kumakain ako nun, tapos nabalitaan ko yun. Sabi na, Charles Law yun, di ba? So ano yung kwento doon? Na? Kasi whenever the temperature is increasing, ano nangyayari sa gases? Na? When you increase the temperature, the gases becomes excited. No? The energy that they get from the high temperature, yun yung reason ba't sila nagiging mas magalaw, no? So, yun. So, since magalaw-galaw yung gases natin, ano mangyayari? So, yun. They will occupy bigger volumes, no? So, mas lalaki yung volume ng gases doon. When you place alcohol kasi in a hot car, no? When you say hot car, yun yung car na naka-off, tapos nakabilad sa araw. Hot car tawag nila doon, no? So, when you place alcohols in the hot car kasi, the alcohol, no, actually yung init sa sakyan, that is enough, no, to cook eggs, no. Actually, nangyayari yun sa ibang bansa, no. Nagluluto sila sa loob ng hot car. Kasi ganun talaga kainit sa loob ng sasakyan pag hindi siya naka-aircon, no. So, yan. So, yan. Ang nangyayari kasi is that there is enough energy, no? There is enough thermal energy for the molecules of gases to expand, no? And also given the idea that yung ating alcohol, they boil off easily. So mabilis silang mag-evaporate. So mas lalong dumadami yung gases sa loob ng alcohol bottle, no? So since ang bottle hindi naman malakas yan when it comes to handling pressures, no? Sasabog talaga 'yon, no. Medyo malakas yung pagsabog kasi nakita ko sa balita yung window nasira ba. So gano'n, no, gano'n katindi, no. So yun lang yung idea, no, with Charles' law, no. As you increase the temperature, the volume increases, no. That means the gases want to occupy more space kasi mas magalaw sila, no. Ayaw kasi ng gases na dikit-dikit sila, no. Gusto nila hiwa-hiwalay sila. Gusto nila spread out sila, no. So that's the idea for Charles' law. Okay, so they are directly proportional. If you increase the temperature, the volume of the gas increases. No? But if you decrease the temperature, the volume will decrease. One example of it is that, kunwari may balloon ka, no? Galing ka sa Jollibee Christmas, Jollibee party, kumuha ka ng lobo, ilagay mo yun sa ref, no? After some time, the balloon will shrink, no? Bakit? Malamig kasi, no? Parang tao lang din yung gases, no? Kapag malamig, nagdidikit-dikit yung mga particles, no? Kumbaga sa tao, yun yung mga sinasabi nilang cuddle-cuddle, no? Yung mga gas particles, nagdidikit-dikit din sila, no? Kasi malamig, no? So, yun. Kapag malamig, the gas particles will come together. That means the volume will shrink. Pero kapag mainit, the gas molecules will expand, no? Maglalayo-layo sila, no? So, yun yung idea with the Charles law. Kaya may ganyang proportionality. Okay, so again, we can remove the proportionality by introducing a constant. So, this is not proportional symbol anymore, equal sign na yan. Then, this is the equation that gives us the constant V over T equals constant. No? So, the ratio of the two factors, itong ano natin, V and T natin, yung ratio nila or yung constant, that is the same all throughout, no? Kahit anong gawin mo sa gas mo, same yung kanilang constant, no? So that means kung ano yung initial condition constant mo, that is the same as the final condition constant. So we have this equation. We can combine them as V1 over T1 equals V2 over T2. No? So this is the Charles law. Kailangan niya ba ito kabisaduhin? Kahit hindi na, no? Ako personally, di ko alam yung mga pangalan, no? Basta alam ko may ganyang equation. Ayun, kasi ako ginagamit ko PBNRT lang, tapos tinatakpan ko lang yung mga hindi kailangan. So, ganun yung life hacks ko. So, next one is the Gay-Lussac's law. No? So, what's with Gay-Lussac? No? So, the analogy is similar with Charles' law. Actually, medyo magkasama sila nung binuo nila to. No? Si Charles' law, volume and temperature yung idea niya. Si Gay-Lussac naman, pressure and temperature yung kanyang idea. So, according to Gay-Lussac, if you increase the temperature, the pressure will increase as well. So imagine it as yung gas molecules nga having energy, no? Mataas yung energy nila kapag mainit, no? So if mataas ang energy, that means yung mga molecules magbabanggaan more frequently. Mas lalo silang magbubungguan sa isa't isa, no? And when they collide with one another in a more frequent fashion, ibig sabihin mas tumaas yung frequency ng pag-collide ng mga molecules kasi malikot sila. That means mataas yung pressure, no? So kapag maraming molecules na bumabangga sa isa't isa, that means mataas yung pressure, no? So that's why temperature is directly proportional with pressure, no? So one example uli, dahil medtech kayo, syringe, no? So yung syringe, no, syempre walang needle sa dulo. Try nyo i-push yung ano, yung I don't know kung ano yung tawag sa dulo, no? Basta i-push nyo yung nandun sa dulo. Mafe-feel nyo na yung gas na nandun sa loob ng cylinder, umiinit yon, no? Bilisan nyo yung pag-push. Mafe-feel nyo yun as mainit, no? Hindi naman ganun katindi yung init, no? Pero medyo noticeable yung init. Tapos, kapag hinila mo yon, lalamig. Nangyayari yan, no? So, yun lang. So, another example would be your, let's have, itong Lysol, kunwari. No? So, itong Lysol, mataas yung pressure sa loob, no? Pero kapag ito pinisil ko, ano nangyayari? Yung pressure sa loob ay nagde-decrease. Hence, lumalamig yung container, no? So, yan, no? Kaya kapag every time na nagpe-press kayo ng mga canned stuff like Lysol, nafe-feel nyo, uy, lumalamig, no? Ang reason why, ang reason bakit lumalamig is that the pressure inside decreases, no? So, as the pressure decreases, the temperature as well decreases, no? So yan, kunwari, meron kayong mga body spray, no? Pag in-spray mo yan, mafe-feel nyo lumalamig yung can, no? Kasi dahil dyan sa Gay-Lussac law. Okay? Then actually, pinag-combine nila to form the combined gas equation, no? Pero hindi na natin naanohin yan. That's high school masyado. So anyway, so we can remove the proportionality by introducing a constant, K. So solving for K, we have P1 over T1 equals K, no? So kung ano yung constant in the initial condition, that is the same as the constant sa final condition, no? So hence we have this equation, P1 over T1 equals P2 over T2, no? So again nga, sabi ko nga, pinagsama nila yan to form the combined gas equation. That's P1 V1 over T2 over T1 pala equals P2 V2 over T2. No? Kapag samahin mo lang yung volume, no? Ilagay mo lang dyan. Okay, so yan lang. Let's have another one, Avogadro's law, no? So Avogadro's law, ano lang kwento neto ni Avogadro, no? So, alam natin, Avogadro is known for the stoichiometry stuff, no? Stoichiometry. GG, no? So, stoichiometry, that means mga number of particles, no? So, here's the idea of Avogadro. If you have more particles or more moles of gases, no? That means they will occupy much higher volumes, no? Imagine that as mga tao sa isang event, no? If you're going to host a party for 5 persons, no, hindi ka naman magre-rent ng Araneta Coliseum, no. Pwede na yun sa bahay lang, sa living room, no. Pero if you have, let's say, 50 people, you will do it in an events place, no. So you have to have a function hall to accommodate the people, no. Pero kunwari ikaw, naging sikat na singer ka, no, as mag-hold ka ng concert, you have 10,000 people, no? So, you have to have bigger volumes, no? Kailangan mo na magrenta ng Araneta Coliseum o kaya ng Philippine Arena, no? So, ganun yung idea, no? The more people you have, dapat the volume must be big, no? Para hindi compressed yung mga tao. So, that's the same for gases, no? So, if you have many gas particles, that means the volume will be increased as well, no? So, kakalat kasi yung mga gas particles na yun, so they will occupy bigger volumes, no? So, this is the proportionality equation. Volume is directly proportional with the number of moles of gas, no? We can remove proportionality by introducing constant equals Kn. Solving for K, we have V over N, no? And again, kung ano yung constant in the initial condition, that is the same as the final condition. So combining the equations, we will have V1 over N1 equals V2 over N2 na. So, yun lang. And lastly, ito na yung pinaka resolution ng lahat ng gas laws, no? So, ito na yung pinagsama-samang puwersa ng mga gas laws. We have the ideal gas equation. So, this is a combined idea from Boyle's. Gumagana ba? Yan. So, kinuha niya yung idea ni Boyle's, no? Yung P and volume. Ano pa? Yung kay Charles, no? V over T. Ano pa? Kay Gay-Lussac. Hindi. Hindi kay Gay-Lussac. Pangalan nun, Avogadros. Yung V over N, no? So, pinagsama-sama yan, mga equation na yan, to create this entire equation, no? Okay, so kinuha nila yung in terms of volume, no? So, sabi ni Boyle, yung volume inversely proportional with pressure, kaya andun siya. Sabi ni Avogadro, volume is directly proportional with moles of gas. Sabi ni Charles, volume is directly proportional with temperature. So, pag ginawa mo yung equal sign, you will have a constant. Instead of K, ginawa yung R, no? This is the ideal gas constant. O you cross multiply P, you will have PB and RT, no? Okay, so wherein the R is the newly defined gas constant, and it has now a value, no? So the value of gas constant is this. Mali yung units ko kasi ilang taong ko na ba itong ginagamit? Medyo matagal ko na ito ginagamit, di ko pa rin naayos, no? Okay, so this is the gas constant. It has a value of 0.08206 liter atmosphere per mole Kelvin. No? So this must be the unit. No? Ito yung mga suggested unit for pressure, volume, moles, and temperature. No? So ito yung mga correct units. No? Liter dapat, atmosphere dapat, mole dapat, and Kelvin dapat. No? So that means lahat ng temperature na gagamitin natin will not be expressed in Celsius. Rather, we will use Kelvin. No? Okay, so ano pa? The conditions at 0 degrees Celsius and 1 atmosphere is called the standard temperature and pressure. No? So, STP yung tawag dyan. No? So again, when we see STP, that means the temperature is 0 degrees Celsius or 273.15 Kelvin and the pressure is 1 atm. Okay, so given na agad yan pag nakita nyo yung STP, no? Okay, so yun lang. Again, lahat ng temperatures ay naka-Kelvin, okay? Okay, so yun lang yung idea, na. Okay, so let's synthesize all the equations that we have, no? Pagsama-samahin na natin yan, I will answer some problems, representative problems lang. Then, I will give you some items for you to answer, no? So, ayan, nakalagay na dyan, no? Ito yung mga sasagutan nyo, 10, 11, 17, 21, 22. Post nyo na lang uli sa Canvas, no? Okay, so, yan. Hanapin nyo lang yung PDF na to, no? Itong Chapter 5 Gases PDF. Download nyo na lang. Okay, so I will, pwede nyo rin sagutan lahat. Kayo bahala. Kung marami kayong time, go lang, no? Actually, you have plenty of time, no? After this, wala na tayong i-discuss. Preparations for the midterm na lang naman, no? Ayan, kung marami kayong time, sagutan nyo yung lahat, no? Sige lang. Hindi ko kayo pipigilan. Pero ito lang. Ito yung mga suggested items ko na sagutan nyo, no? Okay? So, yun lang. Hindi ko pa pala nalagay yung 20. Yan. Okay. So, 6 yung sasagutan nyo. Ako 5 lang na. Ganun talaga. Okay, so I will answer some of the items, no? So, alam nyo naman to. Pero, let's go back sa basics, no? Okay. So, number 1, if 22.5 liters of nitrogen at 400, hindi. Bay, malabo na mata ko. 748 millimeter mercury are compressed to 725 millimeter mercury at a constant temperature, what is the new volume na? Okay, so ano yung mga given info sa atin? We have volume and pressure. So that should suggest us na ang gagamiting equation ay Boyle's law. No? So Boyle's law yan kasi you have pressure and volume. No? Okay, so again, Boyle's law, sabi doon, P1 V1 equals P2 V2. Now we are looking for the new volume. No? So we have to solve for V2. May katabi siyang P2. So we have to divide both sides by P2 para mag-cancel. Dito lang pwede yung cancel culture. No? So cancelled. No? P1, B1, P2. And so na-cancel na yung P2. No? Cancel. So we can now solve exclusively for volume 2. No? Okay, so this will be our working equation. Volume 2 equals P1 V1 over P2. Then we can now plug in all the information given. No? So again, sabi ko nga, yung lahat ng binibigay in the first part of the sentence that will correspond to your initial state and the information on the latter part of the sentence, yung mga nasa dulong part ng sentence, yun ay yung mga second state, no? Yung 1 and 2, no? So, yung 1 nasa harap, yung mga info, yung 2 nasa dulo parate, no? So, ganun yung format niya. Okay, so, this 22.5 liter would be my initial volume. Natong 748 mmHg, this will be my initial pressure. Atong 2, that means papunta sa next state, no? So, this will be now my second pressure and I will be solving for the second volume na. Okay? So, plug in na lang. So, lipat ko lang dito. Hindi, okay na yun. Ito na lang. V2. Solve na natin, no? So, plug in lang yung info P1 748 mmHg. Volume 1, 22.5. Pressure 2, 725. Then, dapat yung units magka-cancel, no? So, yan. Just observe the proper units, no? Kasi baka mamaya magkaibang units yan, then you have to convert, no? But if they have the same units, edi good to go yan, no? So, allow me to solve for it, no? Teka lang. Yan. Madilim na eh. 748. So, the final volume would be 23.21 liters. Okay. 2 decimal places ulit, no? So, yun lang, no? Anyway, para may circulation ng air. Okay, so 2 decimal places as always, no? So, that would be the final answer for the item 1. So, don't worry, I will upload this sa ating chat box after the class, no? I will now answer number 8, no? Proceed tayo sa number 8, no? Basahin natin yung problem. Sabi dyan, if 15 liters of neon at 25 degrees Celsius is allowed to expand to 45 liters, what must be the new temperature to maintain constant pressure? So, ano yung mga given info sa atin? We are given the volume of neon and the temperature. So ano yung equation that relates volume and temperature? That's Charles' law, no? So according kay Charles' law, V1 over T1 is equals to V2 over T2. Para hindi kayo malito sa pag-solve, no? I-cross multiply nyo muna to, no? Teka lang. Yan, hindi ko makita eh. So i-cross multiply nyo muna to para hindi kayo malito mamaya, no? Okay, so yan. Tapos ano yung hinahanap sa atin, no? Tingnan muna natin yung problem. This is liters of neon at 25. So this will be my initial volume and initial temperature. This will be my final volume and I will solve for the final temperature, T2. So para ma-solve ko si T2, ano gagawin? May katabi siyang V1. So I have to cancel V1, no? So cancel V1. Okay? So we can cancel that by dividing both sides by V1. Hence, we will have the equation T2 equals V2 T1 over V1. Then we can now plug in all the information that we have, no? Right ko lang, yan. Okay. So, volume 1, volume 2 pala, that's 45 liters. Temperature 1, again, when we use temperatures, it must be in Kelvin units. No? Kailangan naka-Kelvin yan, hindi Celsius. So how do we convert Celsius to Kelvin? Just add 273.15. No? So mag-add lang tayo ng 273.15 dyan. That will be 298.15 Kelvin. Okay? So ganun lang. And then volume 1. What's the volume 1? That's 15 liters now. So basically, multiply mo lang pala siya sa 3, no? Okay, so the final temperature would be 894.45 Kelvin, or kung nga gusto ko ng Celsius, you just deduct 273.15 to it, no? That's 621.3 degrees Celsius. Okay, so ganun lang. Anyway, multiple choice naman yung quiz as always, no? So, ayan. Malalaman nyo naman kung anong units yung gusto ng problem. No? Just look at the choices. No? Ayan, so easy lang, di ba? Easy. Kayang-kaya nyo sagutan yan kahit di nag-lesson dito eh, no? Oh, ganun talaga. Dali lang to eh. Let's proceed with number 9. No? So, number 9, the gases in a hairspray can are at a temperature of 27 degrees Celsius and a pressure of 30 pounds per square inch. No? So, yung 30 pounds per square inch, ito baka naninibago kayo. Ito yung PSI unit, no? PSI yan. Saan nakikita yung PSI? Sa gauge ng pressure ng car, no? Saan pa ba? Sa water tank, mga naka-PSI yung units na, no? So, pressure units yan. Again, when they say pressure, force over area. Yung pounds ay force, ang inch square ay area. No? So, pressure unit yan. So, we can use that na. No? Kasi, yung unit naman ng kabila is pounds per square inch. Then, no? Pero kunwari, ito atmosphere, ito pounds per square inch. Then, we have to convert. No? Okay, so hanapin nyo na lang yung conversion factor. No? Okay, pero anyway, hindi naman natin need. So, okay lang. So, sabi dyan, no? If the gases can reach a pressure of 90 pounds per square inch, the can will explode. Sasabog yung lata. No? To what temperature must the gases be raised in order for the can to explode? Kailan daw siya sasabog? No? Anong temperature daw? So, solve natin. No? So, ano yung info na binigay sa atin? We have pressure and temperature. So, that should give you an idea that we are pertaining to the Gay-Lussac law, no? Pressure and temperature relationship. No? So that's P1 over T1, P2 over T2. So again, para hindi tayo malito mamaya, cross-multiply mo na lang muna yan. T1, P2. Okay? Then, hanapin natin. We are solving for the final temperature. No? So, we are going to look for T2. That means we have to divide both sides by P1. No? So, they can be cancelled. No? So, our working equation now would be T1, P2 over P1. Okay? And plug in na lang. No? Initial temperature. That's 27 degrees Celsius. Again, we do not use degrees Celsius. Even Fahrenheit, no? Bakit kaya, sir? Ganito kasi, no? Those units will those units might give you a negative answer or zero answer. Hari, minultiply mo yan lahat sa 0 degrees Celsius. E di wala, no? Ano yung magic, no? Oh, biglang nawala, no? Walang ganon. Okay. So, hindi rin pwede magkaroon ng negative, no? Ay, may utang pa, no? So, yan yung reason why we we do not use those units, no? Kasi they will give you negative answers or zero, no? Which is not good, no? So, that's why we use Kelvin. Ang Kelvin is always positive naman, no? Okay. So, we have to convert 27 degrees Celsius to Kelvin. That's 300.15 Kelvin times the pressure 2, which is 90 pounds per square inch. PSI na lang sulat ko. And then 30 pounds per square inch for the initial pressure. Basically, you have to multiply the temperature by 3 now. So that's 945 Kelvin or 627.3 degrees Celsius. No? 627 degrees Celsius degrees. Okay, so ganun lang. Easy, di ba? Tapos pagdating sa quiz, no? Bulaga. Hindi. Madali lang yung quiz. As in. Okay, so anyway, so let's proceed with the last two items, no? So, ito naman, let's check the problem, no? Kung ano pwede gawin dito. Calculate the volume occupied by 2.12 moles of nitric oxide at 6.54 atmospheres and 76 degrees Celsius. Okay, so mapapansin nyo, you have multiple given, no? Ang daming given. May mga given. Moles, meron kang pressure, meron kang temperature. So, if that's the case, that means you have to use the ideal gas equation. Ganun na. Pag more, pag maraming variables na yung binigay na, binigyan ka na ng volume, binigyan ka na ng pressure, temperature, amount of matter, ideal gas equation yan. So, you write PV equals nRT. Ano hinahanap? Volume. So, looking at the equation, may katabi si volume, which is pressure, no? So, let's cancel pressure para yung volume lang yung matira, no? Okay. Volume equals nRT over pressure. Okay. Then, well, let's solve for volume, no? N. N is the moles of gas, no? Which is 2.12 according to the problem. R, ano yung R? Gas constant. No? The unit of R is 0.08206 liter atmosphere per mole Kelvin. So, kabisaduhin yan. No? Ay, sa buhay pala. No? Yan. Times the temperature. Again, the temperatures must be expressed in Kelvin. No? So, that's 76 to 73.15. 349.15 now. Okay. Then pressure 6.54. Ay, hindi pantay yung equal sign. Magagalit prof ko. Ayan. Okay, so by the way, do you have to write the units? Yes, no. Para makita nyo kung ano yung mga nagka-cancel. You can cancel the moles, you can cancel the kelvins, the atmospheres, and then you are left with liters, no. Which is correct kasi yung volume must be expressed in liters, no. So ganun. That's one way to see if tama yung sagot mo, no. Or tama yung equation mo. So solve ko lang. Okay, in two decimal places, that's 9.29, 0.08206. Yeah. So that's 9.29 liters now. Okay, so that's the answer. Let's have number 19, the last item now. Okay, so again, if you have more than two given information, you have to employ the ideal gas equation. Yun na yung gagamitin mo. Okay, so let's have this. Volume. Tapos binigyan ka ng mass at STP. Again, when we say STP, temperature is 0 degrees Celsius or 273.15 Kelvin. And pressure is 1 atm. Matik to ha, pag STP. Okay. Hanapin yung volume. So this is PV and RT again. So volume yung hinahanap. Kopyahin ko na lang equation sa taas. Okay. However, tignan nyo. Anong given sa akin? I have mass of ammonia. My equation requires me to have moles. No? So ano meaning nun? I have to convert my moles, I have to convert the mass of ammonia into moles of ammonia. So how am I going to do that? Triangle, no? Illuminati, pilik mata. Tapos mamaya may nangyari na naman sa mundo eh, no? Grams, mole, and molar mass, no? Ang weird, no? Kasi October, kanina lang, symbol kang Taal, naghihimutok na naman, no? So, ala. Grabe na yung 2020. So anyway, so we are going to solve for the moles, no? Again, to solve for the moles, that's mass over molar mass, no? We can actually incorporate that in our equation. Pwede ilagay natin yung mass over molar mass dito. Bakit, no? Kasi if you compute for that separately, magra-round off ka, which is bad, no? Okay lang, pero sayang kasi yung decimals, no? So, yan. So, I want to make use of all the decimals. So, ilalagay ko na lang dito yung mass over molar mass, no? So, etong moles, ay, nawala lahat. I can rewrite that as mass over molar mass, no? Etong molar mass, pwede ko yan ilagay sa denominator, no? So, okay. Rewrite ko lang yung equation. So, that will be mass, molar mass, times pressure. Okay, so ganun lang yung workaround, no? Then, we can plug in all the information that we have. Mass is 5.58 grams of ammonia. R is 0.08206 LATM mole K. Temperature, that's 273.15 Kelvin. Molar mass, no? Molar mass, ammonia NH3. That's 14,008 for nitrogen, 14.0. Tama ba? 007 pala. Plus hydrogen, 1.008 times 3. 17,031 Gmol times the pressure, which is 1 atmosphere. Again, observe that the units will cancel out na. So magka-cancel out ang grams, ang moles, ang atmosphere, at ang Kelvin. So you will be left again with liters and that's good, no? So solve ko lang, no? Okay, so the final answer would be 7.34 liters. No? Medyo marami din pala. No? Okay. So, yan. Makikita nyo, mababa yung density ng gases. No? So, occupying this much volume, gano'ng karaming ammonia lang meron? 5 grams. No? Gano'n po kalaki yung 7 liters. Halos isang galon yan. No? Yung galon na kulay blue, alam ko around 10 liters yun eh. Um, So you just have 5 grams of matter enclosed in that container, no. So mababa talaga yung volume ng gases. Anyway, so that sums up the calculation part ng gas loss, no. So I want you to answer items number 10, 11, 17, 20, 21 and 22 of this worksheet, no. So ang title niyan sa Canvas, punta kayo ng Chapter 5 Discussions, Chapter 5 Gases.pdf, no. Siya lang yung mag-isang PDF doon. Okay, so yan. Screenshot ko to, bigay ko to sa inyo mamaya. After the class, no. Okay, so ngayon, let's proceed with the next one naman, no. Gas stoichiometry. Kasi sometimes sa ating stoichiometric problems, hindi lang grams ang kailangan, no? Especially kapag gases yan. Minsan hinihingi ay volume, no? Hindi mass, no? So, paano uli yung scheme ng ating stoic questions, no? So, ang scheme ng ating stoic question is that you have the mass of your matter, ko-convert mo siya sa moles, then, i-convert mo yung moles ng isang substance to the other substance using the stoichiometry, then you will convert moles back to grams, no. However, if we have gases, no, hindi lang mass yung pwede. We can also use volume, no. Kasi the volume tells us about the amount of matter as well, no. So kunwari you are given or you are required to state the answer in volume, volume yung hinahanap, hindi mass, then you have to employ the use of ano tawag doon? Ideal gas equation. No? So, ideal gas equation ang kailangan whenever you see volume. No? May nakita ka mga required volume. No? So, ideal gas equation yan. So, yung format ng stoichiometry, that's the same as this time. No? So, pare-parehas lang tayo ng gagawin dito. Okay, so, ayan. Let's answer some problems. No? So let's try this one. Sodium azide is used in some automobile airbags. No? So, depende sa sasakyan. No? Pag nabunggo yan, biglang mag-open yung airbags. No? So, bakit? Ganito kasi, no? In cars, no, sa mga car na may airbags, ang nangyayari is that kapag bumunggo yung car, may magka-come into contact na metals, no. So nasa harap 'yon, alam ko eh. So pag nagdikit yung dalawang metal na 'yon, kapag nagbungguan, that will cause spark, no. Magi-spark yung container with sodium azide, no. And when we have sodium azide na nag-spark, no, it can combust, no. It can combust to produce nitrogen gas, no. So pag nag-combust yung sodium azide, no, nag-decompose siya, magiging gas yung powder na yan, no. Okay, so ganyan lang yung idea, no. So yan. So the impact of collision triggers the decomposition of sodium azide as follows. Balance na to, no? So 2 sodium azide producing 2 sodium plus 3 moles of nitrogen gas. Kaya mabilis yung pag-inflate nun. Ganun talaga. The nitrogen gas produced quickly inflates the bag between the driver and the windshield and the dashboard. Calculate the volume of nitrogen gas generated at 85 degrees Celsius and 812 millimeter mercury by the decomposition of 50 grams of sodium azide. No? So, gawa muna tayo ng schematics. No? Gawa tayo ng scheme ng answers. No? Paano yung format? No? So, Ano yung given info sa atin? We are given the amount of the reactant, no? Sodium azide. So, meron tayong grams of sodium azide. Ang gusto natin sa dulo ay volume of nitrogen gas. So, medyo mahaba-habang conversion yan. So, yung grams of sodium azide, we have to convert that into mole sodium azide, no? Then after converting that to mole of sodium azide, we can now convert it to the nitrogen gas, no? Yung mole na to, pwede convert na doon sa mole ng N2. Okay? Then eventually, yung mole ng N2, we can convert it to volume by using the ideal gas equation. Okay, so typical Stoic calculation na. So gawin natin yan. Ano ba? Convert muna natin grams nito to moles. No? Sige. So mole sodium azide, that's mass over molar mass. Okay? So, ano yung mass? 50 grams, di ba? 50 grams divided by molar mass. Solve ko lang. 22,990. 22,990. So that's 65 G mol. Again, yung decimal places, kumpletuhin muna natin. 50 divided by 65,011. Mole of NaN3. Okay, so we now have mole of NaN3. Tapos ngayon, ang gagawin natin, we are going to convert the moles of sodium azide to mole of nitrogen gas. We can do that by using stoichiometry. You check the balance equation. No? Ito yung gagamitin natin, conversion factor. Okay, so we begin solving for the mole nitrogen gas. So we have mole of NaN3 first. Kasi convert natin yan to nitrogen gas. So nasa baba yung mole ng sodium azide, nasa taas yung nitrogen gas. So ano yung kulang dito? Dito. Yung coefficient ng mga substances. Now, just look at the equation. So sodium azide, that's 2 ang coefficient. Ang nitrogen gas, that's 3. So, you multiply this with this number. So, multiply ko lang 3 over 2. So, that will give me 36 pala. 3650921 mole of N2. Dami, no? So, yung ganyang karaming moles of nitrogen gas ang meron when sodium is 50 grams of sodium azide decomposes na. So, yan. So, ngayon, ang kailangan ko ay volume, no? So, from mole of N2, I need volume. So, I can do that using PV nRT, no? So, recall PV equals nRT. So, you have moles na, no? You're going to look for the volume. So, this volume equals nRT over P. P pala. Yan. Okay, so copy ko na lang, no? So, mole of nitrogen gas, 1,536,50,921 mole. Gas constant is 0.08206 liter atmosphere, mole Kelvin. Temperature, ano yung temperature? 85 degrees Celsius, no? 85 plus 273.15. That's 358.15 Kelvin. Pressure is 812 millimeter mercury. Ayan. Okay na ba yan? Hindi. Bakit? May millimeter mercury. magpanic ka pag ganyan. Kasi ang kailangan doon ATM. Ang meron tayo MMHG. So, paano yan, no? So, we have to convert, no? Wag magpanic, no? Again, 1 ATM is just 760 mmHg lang. So, convert lang natin, no? So, lagay ko na dito yung conversion. So, nasa baba yung mmHg. So, we can cancel them later. Sa taas yung ATM. 760, 1 ATM. So, yun na. Wag magpapanic. Chillax lang. Cancel. Cancel yung ATM. Cancel yung mole. Cancel yung Kelvin. You're left with liters, no? So, ganun lang. So, ganun lang ka-easy, di ba? So, yan. Solve ko na, ha? Wait lang. Mahaba-haba to. So, again, ha? Pag iba yung unit, you can convert them. Uh, yan yung mga conversion. 1 ATM, 760 mmHg, equal din yan sa 760 torr, equal din yan sa 101,325 pascals, no? So, yun yung mga conversion. Kaya, wag magpanic, no? So, the final answer here in 2 decimal places is 3173 liters. No? Dami nun, ah. Kaya pala yung airbag sobrang laki, no? Kapag na-trigger siya. So, ganyang karaming volume ng gases pala ang meron na when sodium azide decomposes. It's 31 liters. Okay. So, ganun lang, no? Whenever you have a stoichiometry problem that involves gases, no? Pag involve yung gases doon, you can just convert the volume, the pressure of the gas, no, into moles ng gas by using the ideal gas equation. So, ito lang yung pinaka-key addition, no? So, itong ginawa natin dito, stoic yan. Chapter 4 yan. Itong ginawa natin dito, chapter 5, no? Gases lang yan, no? So, ganun lang. You do kung ano yung ginawa natin last time, no? Tapos ito, additional lang. Okay? So, kayang-kaya yan, no? Okay, so we're done with the third part of our discussion. Last part is madali na lang. So, ibig sabihin nun, maaga tayo matatapos? Yes po, no? At matatapos na ang first half ng ating semester. Hanapin ko yung PowerPoint. Ito, gases. Ay, hindi yan. In-upload ko yung mga PowerPoint sa chapter na to, no? Nandun sa Canvas. Chapter 5, gases. Ay, hindi yan. Ano ba pinipindot ko? Kalang. PowerPoints. Bettelheim. Ito. Ayun. Ito lang naman. Yan ang kailangan natin. Okay, so last one would be Dalton's law of partial pressures. So, according to Dalton's law of partial pressure, ang meaning niyan lang dyan is that if you have combined gases, no, pag pinagsama-sama mo yung mga gases, their total pressure is just the sum of the partial pressure of individual gases, no. So, kunwari, may friends kayo, no, tapos you exert pressure, no. Kunwari, tinutulak nyo yung car, no. Kunwari, 3 kayong tao. So, yung total pressure na ine-exert nyo sa car as you push it is the sum of the pressure exerted by person A, person B, and person C, no? So, yung total na pressure na nabigay nyo sa car, yun yung added pressure ninyong lahat, no? So, ganun din sa gases, no? So, when you combine the pressure of gases, no, you have the total pressure, no? Okay, so madali lang yung calculation dito kasi basic lang naman to, no? So, PT is equals to partial pressure of first gas, the second gas, third gas, so on and so forth, no? So, madali lang tong addition, no? So, for example, to a tank containing 2 N2 at 2 atmosphere, O2 at 1 atmosphere, and we add an unknown quantity of CO2 until the total pressure in the tank is 4.6 atm. What's the partial pressure of CO2? So, madali lang gawan niya ng equation. So, paano yon? So, the total pressure is equal to the pressure of nitrogen gas, the pressure of oxygen gas, and the pressure of CO2. So, if the total pressure is 4.6 atmosphere, 2 atm doon ay kay nitrogen, kay oxygen ay 1 atm. So, it's a matter of just solving for the value of x. No? Now, solving for the value of x, that will give you 1.6 atm of carbon dioxide. So, yun lang yung basic info niya. And with that, tapos na tayo, guys. Tapos na ang inorganic chapter natin. No? So, that means midterm period na. Okay, so good luck na. So, ano yung uli yung mga kailangan ko i-remind sa inyo? If you want to watch, if you want to watch lecture classes ko, just go to the YouTube channel, no? Siyempre, kailangan yung may link kayo, no? Punta lang kayo dito sa announcement, no? Ito, announcement. Punta lang kayo dyan. Hanapin nyo yung recorded class discussion. Okay, so ayan. Hanapin nyo lang dyan yung lecture na gusto nyo, yung chapter na gusto nyo aralin ulit, no? Okay? So, pwede nyo naman gamitin yung recordings ko sa ibang classes. Kaya nga nakapost yan dyan lahat, no? Nari, gusto nyo mag-aral ng org chem. Sige, manood ka ng org chem. Okay, so ganun lang, no? So, ganun lang yung mga bagay, no? Kung gusto nyo ng lecture ng ibang class ko, sige, manood kayo dyan, no? Basta ganun, no? You are free to use the materials that we have discussed here, no? So, for the final reminders, again, quizzes, quiz 4 and quiz 5 will be due on October 11. But it doesn't mean that you have to do it on October 11. No? Pwede nyo na siya sagutan mamaya. Pwedeng next week na lang. Ano ba gagawin natin next week? Technically, wala tayong gagawin. No? I want you to prepare for the quiz. No? I mean the exam. Kasi malapit na. No? Dun, magkakaroon na kayo ng tentative grade nun. No? So what I want you to do is that if you have any questions, no, and you want to clarify it, we can meet. We can meet sa Monday and Thursday, no. Kunwari, sir, paano to sasagutan, no? So ganun. Send nyo muna sa akin yung questions, no. Sasagutin natin, no. Itanong mo kay Jim, ganun, no. Magkakaroon tayo ng Q&A portion. So yun lang. But if you do not have any questions, that's fine with me, no? So, yan. Just do well in your exams, no? So, we will have a short break next week, no? Then, although pwede kayong magtanong, ha? Kung gusto niyo magpa-conference call, di sige, okay lang. Basta within our class schedule, no? Yan. So, review well and do well. Good luck sa midterm. No? So, college na kayo, no? So, kailangan matatag na kayo. No? Ayan. So, hindi porket mababa sa midterm ay mababa na rin kayo sa finals. No? Sir, ilang items po? Usually, the midterm exam is 50 points, 50 items no, in total. 2 points each para maging 100 points. No? So, yan. So, 10 questions per topic. Ganon usually. Hindi. Dito lang ata sa subject namin, yung 50 items. Kasi yung ibang subject, may iba silang policies eh. Pero sa amin kasi sa chemistry cluster, usually ganun ginagawa namin. No? 50 items, 2 points each. So, yan. Sa ibang subject, alam ko merong nagwa 100 items eh. So, good luck kung may ganun kayong subject na. Pagpapalain kayo ni Lord. No? So, galingan nyo na lang. Ito pala, no? One concern is the internet, no? Connectivity, no? Sir, paano yung mga hindi makakonect sa internet? No? So, The department is yet to inform us kung ano yung magiging process, but I know they will be lenient na. Mas magiging ano sila, accommodating for sure. Kasi alam niyo naman, situation natin, buti ba kung nasa ibang bansa tayo, but dito tayo sa Philippines, so mabagal talaga yung internet. So, ma-understand naman yan. No? Ako personally, pwede ko naman bigyan kayo ng ano, another take, no? Pero, we will wait for the department's instruction muna. No? Pero yun, so don't worry. Kaya yan, no? So, yan. Any questions?
Sir,
Right. Yes po.
sabay-sabay po ba yun pag magte-take na ng midterm exam?
When taking the midterm exam, kasi that will be scattered in 3 days, no? So, for our case, sa aming cluster sa chemistry, hindi kami yung iba kasi, awan ko, may plan ata sila to have synchronous exams, no? Pero sa amin, alam ko hindi na kami magpapaganon for the reason na yung internet natin that is not always fast at all times naman, di ba? Minsan mabagal pa rin, no? Kahit umaga, no? Kaya yung iba nag-exam ng madaling araw. So, yan. So, most of the time, kanya-kanyang take ng exam na. So, yun. In a span of 3 days. So, yun.
Salamat po, sir.
Okay po. May question pa yung iba o gutom na? Okay na ba tayo dyan? Okay, so, yun lang naman, no? Again, ano kailangan ko sabihin sa inyo? Yun lang naman. So, good luck with the quizzes. No? Then, if you can answer it next week, no? Sige, sagot na kayo ng quizzes, no? Para may time kayo to focus on the exam itself, no? So, again, pag mag-review kayo, punta lang kayo sa ating channel. Punta lang kayo dito. Andyan naman lahat ng lessons from day 1 until chapter 5, day 1, no? So, yan. Ipopost ko mamaya yung chapter 5 dito. Okay, so yan. Mag-binge watch kayo, no? Sabay nyo siya sa Netflix nyo, no? So, yan. Nood na lang kayo niyan. Okay? So, yun lang. And good luck, no? And with that, no? Siguro, we are done with the class discussion na today, no? So, thank you for your participation, no? So, basta any concerns, no, na nagbabother sa inyo, just let me know, no? Naunawaan ko naman yung situation natin lahat dito, no? So, if you want to watch my lecture videos, you may, no? Pwede kayong manood nun. Kung gusto niyo manood uli ng lab videos, edi sige, nood uli kayo ng lab videos. Mag-scroll lang kayo sa YouTube natin, ha? So, yun lang. And I wish you well. Sana yung internet next week ay stable na stable until the examination. Okay. So, yan. Na all labs, sir. Ganun talaga, no? Okay. So, yun lang. And I'll see you again on, I don't know kung may meet tayo sa Monday, pero yun nga, no. If you want some synchronous discussions, no, review, sige, just let me know. Okay. So, yun lang. And stay safe always, no. Bye-bye. And kain na po ko tayo. So, yan.
Thank you,
So,
sir.
good luck.
Good night po.
Bye-bye. Okay.
Thank you, sir.
Opo. Salamat. Bye-bye din po.
Bye, sir.
Thank you, sir.
Thank you, sir.